Today's lesson is on solving quadratic equations by the factoring and square root methods. So first off, the quadratic equation in standard form is ax squared plus bx plus c equals 0. So this is any quadratic equation. Notice it has to have a squared in order for it to be quadratic, and then in standard form we put all the terms on one side and then it has equals 0 on the other side. So in this unit, I'm going to teach you 4 methods of solving quadratic equations. And when it is most convenient to use each method. So the 4 methods that you're going to learn this unit are first, factoring. Second, the square root method. Which some books call extraction of roots. The third one is going to be completing the square. And the last one will be the quadratic formula. We are going to cover the first 2 methods in this lesson, factoring and square root method, and then the last 2 methods actually in the next lesson, completing the square and quadratic formula. So for the first method, factoring, when do you want to use factoring? Well, this is one of those that I always try first. Because factoring is very simple and it comes out very quick if the quadratic equation factors. But not all quadratic equations are going to factor, which is why we need the other methods. But this method I always like to try first because it's quick and fast and easy if it factors. In order to factor, we use the following steps. Number 1, put the quadratic equation in standard form. Meaning I want one side to be equal to 0. 2, I want you to factor the expression. 3, set each of the factors with a variable in it equal to 0. 4, use the zero product property to solve. So what is the zero product property? Well, if you have a times b equals 0. So you have some expression where a is being multiplied by b and you know the result is 0, then one of 2 things has to be true. Either the first factor a has to be equal to 0, or the second factor b has to be equal to 0. That's the only way you can multiply 2 as 0 is if one of the factors is already equal to 0. So the zero product property is going to help us solve quadratic equations by factoring. So look at the first one, negative 14x squared plus 21x equals 0. Step 1, is it in standard form? Well, sure it is. All of the terms are on one side and it does equal 0. Now I see that there is a term missing, but it is in standard form because all of the terms are on one side. Second, factor that expression. So it looks like in this expression I have a binomial. First step is always GCF, and it looks like I can factor out a negative 7x. Because there's a negative in front, you always want to factor the negative sign out if that's the first term's sign. Let's see, that leaves me with a positive 2x minus, because a positive divided by a negative is a negative, 21 divided by 7 is 3, and x divided by x is 1, so I don't need to write that. Okay, step 3, set each factor with a variable in it equal to 0. So there's 2 factors here. Sometimes people don't think of the first one, negative 7x, as a factor, but it is. Does it have a variable in it? Well, it sure does have a variable in it, so I'm going to set each of those factors equal to 0. The reason I can do that is because if this thing is like a, and we're multiplying it by another thing b, and if I know a times b equals 0, then either the first factor has to be equal to 0, or the second factor equals 0. It's one of the 2 things. One of the 2 parentheses needs to be equal to 0 in order for the whole thing to multiply out to 0. So now I'm going to solve each of these independently. which gets me x is 0 on the left-hand side. So it looks like my two answers are 0 and 3/2. Remember the braces? Just say, oh, the answers are in here. That's set notation for these are the answers for a solve problem. So that is my final answer for that one. On the next problem, step 1 says put it into standard form, and it is. Step 2 says to factor the expression. I always try a GCF first, so let's see if I can't find a GCF here. It looks like I have a 2. 6x squared minus 13x minus 5. Now I still can factor that inside with just the 2 keep coming down. On this problem, I'm going to try guess and check. So my factors of 6 are 1 and 6, or 2 and 3. My factors of 5 are 1 and 5. So I'm going to come off to the side of my paper, and I'm going to try 2x and 3x, and 1 and 5. I'm not sure if this is right, I'm just totally guessing, so I'm getting 3x and 10x. And because this 5 is negative, that means I have to have one of each sign. Can I use one of each sign and get negative 13? No. This is really close. A lot of people might say, oh yes, you can. But because the 5 is negative, that means one has to be positive and one has to be negative on my products. And there's no way I can get negative 13 that way. So let's try it again with 5 and 1. I'm just rearranging the terms. This one gets me 15x, and this one gets me 2x. Okay, with one of each sign, can I add to negative 13? And I can. I put a negative on the 15 and a positive on the 2. And then I come back. Don't forget that the 2 comes down. And then my two factors I'm reading horizontally are 2x minus 5 and 3x plus 1. Okay, so that was step 2, factor the expression. There's nothing else that can be factored, so I'm done. Now I'm going to set each factor with a variable in it equal to 0. So there's 3 factors here. Don't forget that this 2 is a factor. But does 2 have a variable in it? Well, it doesn't. So even if you tried, let's say you tried to set it equal to 0. Will 2 ever equal 0? No, and there's nothing there to solve for because you don't have a variable. So all you're doing is setting each factor with a variable in it, see how this one has an x, equal to 0. You don't have to worry about the ones that don't have a variable in it. And then you're going to solve each of those independently. So I have 2x equals positive 5, divide both sides by 2. So I have x is equal to 5/2. And on the other side, subtract 1. So I have x is equal to negative 1/3. So my two answers are 5/2 and negative 1/3.